Okay, so I'm going to do solutions to problems 33 and 38 in the Giancoli textbook. This is chapter 7, linear momentum, pages 204 and 205. Question 33 is about two cars that collide and stick together and then slide a certain distance. So the first car has a mass of 1 times 10 to the third kilograms. And it's moving with some unknown velocity before the collision. That car collides with a second car with a mass of 2.2 times 10 to the third kilograms at rest. And then the two cars lock together and they slide 2.8 meters along a surface with a coefficient of friction of 0.4. Okay, so the question that they're asking is, what is the velocity of this car before the collision? We want to know how fast that Toyota was going before the impact. So we know that this is a perfectly inelastic collision. The two cars lock together. So we know that we could write m1v1 plus m2v2 equals m1 plus m2v prime. This is the velocity of the two cars locked together after the collision. So 1000 v1 plus, so this is 0, no momentum for the second car, equals, and then they have a combined mass of 3,200 kilograms times v prime. So in order to get v1, we first have to know v prime, and now we've seen something like this before. We want to know what the velocity of the two carts is before they start sliding to rest. So we can use a variety of methods for this. We can find the acceleration, we can use the timeless equation. I prefer to use energy for this because I think it's a little more straightforward. I think the answer comes out a little quicker. So I'm going to use energy. Kf is Ki plus conservative work plus non-conservative work. There's no conservative work here, and there's no final kinetic energy. So we could say 0 equals 1/2 mv squared minus, I think in an earlier video I forgot to put a minus on here, I said plus, but you understand, like, we have to subtract the non-conservative work by friction in this case. So the friction force, which is mu mg times d. And we can see that the mass, again, doesn't matter here, and we're solving for v. So v is equal to the square root of 2 mu gd. So the velocity is going to be the square root of 2 times 0.4 times 10 meter per second squared times 2.8 meters. And that velocity is 4.73 meters per second. Now, we want to use that 4.73 meters per second in our other equation to determine this velocity. So v1 is going to equal, now we can just divide this by 1,000 right now, 3.2 times 4.73 meters per second, and v1 comes out to 15.1 meter per second. Okay, so this is our final answer. This was the velocity of that car before it hit that one, and then they locked together, slid for 2.8 meters with a starting velocity of 4.73, ending with a velocity of 0. Okay, so let's look at question 38. 38 is the first 2D momentum problem, and I'm going to do some 2D momentum instruction a little bit later and post that as well. This is a great introduction to 2D momentum since we have two objects going in at right angles to each other, and we'll see that momentum is again something we can use right triangles to analyze, just like with everything else, with forces and velocities. all vector quantities. So we have an eagle with a mass of 4.3 kilograms going in some direction at a velocity of 7.8 meters per second. And this eagle is going to collide with another eagle with a 5.6 kilogram mass going at a right angle to this eagle's motion, 10.2 meters per second. So if you think about it, what we have are a momentum totally in the x direction and a momentum totally in the y direction. Well, how do we deal with vectors that are like that? We use the Pythagorean theorem to get the resultant vector. But this is a resultant momentum. We can't get a resultant velocity here. Right? We can't just take the two velocities and compose them into a resultant velocity, because this is not two velocities operating on one object, like with a projectile. These are two completely distinct objects, so it's momentum that's conserved here. So we have to get the two momentums and then combine them. Now we could say, generally speaking, that the momentum of any object is, after a collision or whatever, is equal to the sum of, or even before a collision, the momentum of any object is the sum of the total momentums in the x direction squared plus the sum of the total momentums in the y direction squared, the square root of that. It's the Pythagorean theorem. So we could find these two momentums. Right? For example, this momentum would be 33.54 kilogram meter per second, and this momentum is 57, call that px, and we'll call this py, 57.12 kilogram meter per second. So we can compose those and get a resultant momentum. So the square root of 33.54 squared plus 57.12 squared. So our resultant momentum for the system, for the two eagles, if they lock together and make a two-eagle system, 66.2 kilogram meter per second. Now let's say I want to know the velocity. Well, if the two eagles are locked together, then this momentum, mv, applies to both masses locked together. So 66.2 kilogram meter per second equals, so the sum of the two masses, which is 10 point, I'll just put them down, 4.3 kilograms plus 5.6 kilograms times v. So v is 6.7 meters per second. So this is the final momentum of the two eagles, the final velocity of the two eagles. But what's the direction? Well, these two momentums form a right triangle, 33.54, 57.12, and if I want to know the angle of travel relative to the initial direction of travel of the first eagle, I just use tangent, my inverse tangent function. So theta is the inverse tangent of 57.12 over 33.54, and that's about 60 degrees. So our first 2D momentum problem, really not that bad. This is why I selected it as your first one to do on your own. Hopefully this makes sense. More 2D momentum problems to come.